what role do you see the private sector playing in lunar exploration? And what commercial opportunities do you anticipate emerging as a result of the growing activity in lunar activity with the government project? So what are the commercial players and the opportunities that there are for them? And maybe we can start with Daniel, and then we get a comment from each one of the panelists.
Yes, well, thank you for having me, and it's a pleasure to be here with so many great people on this virtual stage. It'd be nice to be in person, but you can't win them all. Certainly there's a lot of activity going on with the lunar environment. And I think we at the Canadian Space Mining Corporation, are involved in a number of facets of what we would call lunar infrastructure and development, and those range from ISRU and space resource utilization to healthcare and energy. And I think there are no shortage of opportunities, economic opportunities for commercial actors in the space. I think there's probably two time frames to think about. And in the initial time frame, you have a number of commercial actors. I don't think there are a ton of purely commercial activities. I think anyone who tells you that it's purely commercial, I think is just not realistic to the fact that that's all that activity is still being backed by and funded by government, and government is still the anchor customer for driving those activities. But a lot of the actual technology and capabilities and operations are probably going to be delivered by commercial companies within that. And I think the NASA CLIPS is a great example of that. Right? Like, these are commercial lunar payloads, but it is funded and backed by NASA, right? It is effectively NASA operating and enabling that market. But it is commercial companies that are bringing innovation in a new and more rapid, iterative way to those markets. And not just NASA, obviously, Canada and the European Space Agency and a number of other groups are developing the technologies which are going to enable that. I think the second question is, what those markets are. And I think there's really a broad range of those markets, right? It's how are we going to operate in the lunar environment? What is the data that underpins that, either from, resource data, ground-based data, geophysics, geotechnical data, the civil engineering that's going to be necessary to enable us to build sustainable presence in the lunar environment, and then all the technology that underpins that. It's a really broad range. And so, I'd say, like, to the other entrepreneurs out there, and certainly to investors, right? You've got to find where you see value within that, because it's not so easy to say that the opportunity is in one or two areas. Obviously, I think there's a considerable amount of opportunity in the space resources part of it, and healthcare and some other areas. But that's my read on that market, right? And where we think we can be effective. But there's certainly a number of areas.
Perfect. Wonderful, Daniel. So thanks for, again, highlighting the breadth of the opportunities that there is. And I definitely agree with the point that there's not yet purely commercial missions. So one we've seen lately was the iSpace mission. So even that was, again, in cooperation still, even though it was fully commercial, it was still in cooperation with the Japanese agency, and they had to license this mission and as well. So maybe George Salazar, maybe you would like to add a couple points as well on that from your perspective.
Sure. I guess I'll add to what Nicholas mentioned. Daniel mentioned. I have to say that there's certainly a lot of opportunities for lunar exploration as part of the Artemis campaign. As you may or may not know, the Artemis campaign is the NASA's approach to learning to live and work on another planet to eventually take us beyond the moon. And so the moon is a proving ground for technologies, and that technologies and processes and procedures and all that kind of stuff are going to be, we're going to have to make sure we wring that out very well before we go on to Mars. Mars is far away. In an emergency, the moon is only a two to 3 day rescue, if you will. Going to Mars, it could be as long as 9 months. So if your life support system fails, you got a problem. If you are out of food, you got a problem. You're out of water, you got a problem. And so these are the kind of the things that we need to wring out in the moon. And I think the commercial sector can help us there. I do have to say there's a lot of challenges and perhaps other questions I can definitely dive into that. But I say from the standpoint of the private sector playing, what roles are that they can play in the pursuit of the Artemis program, the Moon program, and all that is bring in innovation. I have to say the commercial sector is a little bit more, let's call it agile than the government. And so they can be very, very innovative. But, you know, certainly there's still some challenges that we at NASA are trying to grab, trying to understand how we can best handle them. But I think the commercial sector helping out is going to be very beneficial. As far as you know, commercial opportunities, I think Daniel alluded to some, like in situ resource utilization is going to be a biggie. How can we generate water for people on another planet? Okay, so that's going to be obviously critical. Obviously, life support system is going to be critical too as well. You know, the whole area of infrastructure is going to be critical. So I think the commercial sector could play a major role in trying to establish or create or innovate, you know, new ways of living on other planets that perhaps NASA hasn't thought about. You know, again, regardless of whether it's the government, NASA, or commercial sector, you still have these challenges associated with the human element and also technology.
Perfect, wonderful. So in that case, we can move on to my next point, which again, I would like to ask Keval, especially regarding that. So Keval, what role do you see space power playing in, again, supporting the lunar infrastructure development and the lunar exploration?
Yeah, you know, so space power kind of like the aim to distribute power wherever you are in space wirelessly, and essentially using laser beams to make sure, you know, we're not changing the game too much with photovoltaics and the systems that customers would typically need. It's really trying to unlock that huge cost of sending something as far away as the moon and making sure that you're maximizing the efficiency and the value of that. Because if you think about how much space is being used for batteries, it's massive, and they're hot, they get heavy, they give you so many different issues that actually if we can strip that away and even improve the average payload power that you can actually take on board, I think those are the massive improvements that we can make, where you're spending so much time, resource, and cost to get something out there. Being able to make the most of it with thermal imaging cameras and, you know, other high-powered instruments really unlocks and maximizes the scientific value of what you're doing. But really, it's very governmental and governmentally based right now. And, you know, trying to think about the commercial aspect, it is really us kind of like helping out the government agencies and these big programs, because fundamentally there's no market, right? You need to be able to get things back from the moon at the time, you know, at the moment, in order to be able to actually make some cash or to be able to do something. Information is the best way right now. It's the cheapest thing to send back and forth, and I think that's basically where we can see ourselves improving and helping out the government agencies.
Perfect. So thank you, Keval. And as you mentioned again, that it's very much like government-led, right? Still, and there's a lot of, again, policy making that's happening with the Artemis Accords and beyond that, obviously. So maybe I would like to ask Jaden and Bryce on this point more. So how do you see how important it is for the private companies to be working together with the governments when this frameworks and the policy is being developed, and how important is the private companies get to insert their input into that equation?
Can you hear me, guys?
Yes, so we can hear you.
Okay, awesome. Apologies, there's background noise. I'm in Dubai, so it's quite loud. So hopefully you can hear me. So government and industry are tethered at this point and will remain so for the foreseeable future until the point that the lunar settlement has occurred. That's what will bring out people think that it'll be the resource mining and the rare earth minerals and some other external factors that'll bring value to Earth dynamics. It'll be as simple as our settlement up there, because then we will start manipulating the regolith to facilitate growth of plant life, as well as changing out the regolith for other purposes. And then the Earth and the Moon have a cyclical symbiotic relationship through eternity. So the economics will also remain similar. If we adjust the regolith, we will effectively have new ways of using the soil on Earth, whether it's for plant life, or maybe we'll bring back some regolith or some element of the regolith to make concrete on Earth better. These are just examples of some of the ways where just there being a human settlement there will facilitate more economic growth, not only there, but it'll benefit the Earth economy as well. Another would be aquaculture. When we're adjusting aquaculture, raising fish as protein on another terrestriality, it'll help us to do a look back on Earth and optimize and improve our situation here, because we're taking it to an extreme level now. So surely it facilitates better understanding in our Earth dynamic. So as the lunar economy is as simple as when we are present there for an extended period of time, wherever humans go, an economy is developed, irrelevant of whether there's an exotic material found there, because humans have many, many needs, and those have to be fulfilled in that hostile environment. So that'll be the birthing and the growth of the lunar economy.
Perfect, wonderful. And I think Bryce, now the microphone.
Can you hear me?
Yes, we hear you. Yeah, finally.
Yeah. So sorry about
Good
that.
to hear your voice finally. Yeah.
Yeah, I'd like
Go
to
ahead,
add on what Jaden said a little bit about the government and private relationships. That's very key for enabling the commercial lunar activities, in the sense where it's so high cost to send kilograms to the lunar surface at the moment. I mean, we've seen some costs come in at over $1.4 million per kilogram. That's just way too expensive for commercial companies to be, really utilizing large masses on the lunar surface. So essentially, there's a broad range of markets that the lunar operations might entail, but all of it entices refueling in space. So until there's a propellant supply in space that can move high delta V requirements, we won't be able to fully develop there. And that's what Ada Space is working on, is being able to provide cryogenic propellants both in orbit. That's the first step. And then eventually on the lunar surface, where we are taking regolith and providing propellant by splitting the water on the lunar surface. So, yeah.
Perfect. So Daniel would like to add on that. Yeah, please go ahead.
Yeah, I think Jaden made a great point, and so Bryce as well. And I think like the idea that but I would say like Jaden, in some ways you didn't go far enough. Like the idea that we start to see the benefits when we get to the moon and we've established a base there, I think is not going far enough, because I think in getting there, just in developing the technology to get there and to enable those capabilities in the first place, there's a lot of innovation that is already coming out of that. I'm sure we're all seeing in our own spheres about how these technologies were in the early stages of developing for the moon are enabling new activities to happen on Earth and new ways of doing things on Earth. Like we're working on an early stage prototype for a space hospital for the Canadian Space Agency. We're already seeing traction for that technology. Just in 4 months of developing it, we're already seeing applications and interest and how that technology can positively impact people's lives today. We're filling big gaps in healthcare today. That's, long before anyone is going to build a space hospital on the moon, right? So I think like it's really today, and over the next couple of years, you're going to see all this innovation that's been bubbling under the surface as all these companies in their various respects are working on capacities of Artemis and these other missions. It's going to make its way into society for everyone's benefit.
Perfect, wonderful. Yeah, and I see the chain here that's happening, that both Jaden, Bryce, and again Daniel also emphasizing some of the challenges that are associated with establishing the permanent settlements on the moon and really establishing the infrastructure there. So one of the main problems also that is there is probably the communication with the establishing again the proper communication with the moon and between the moon and the Earth. And we see in the NASA's Capstone mission that was again as a test for that as well. So maybe George would like to also comment in terms of the communication and some of the progress that we've had so far with establishing lunar communication.
For the most part, some of the areas that we're looking at in terms of communication is, your traditional RF communications, but they're also the one that we've been doing some development work is laser communication, which provides a little bit more bandwidth, if you will. Of course, there's a few challenges there, but that's the kind of technology. We need some with and things like the deep space network. For the most part, you're lucky to get 30, 40, 50 megabits per second. If we're talking about things like talking to your loved ones, video with your loved ones, and all that, you're going to have to up the video, or rather the communication. So it's not so bad, to the moon. For example, just RF communications, voice communications is 1.2 to a max of 3-second delay. Right now on station, it's just a quarter-second hop, so it's not a big deal. But as you start going to beyond the moon, it's going to get a lot longer. So we need something that can give us a little bit more bandwidth and a little bit faster communications and laser communications. And I think there's been 2 or 3 experiments done already on station associated with laser communications. But of course, you got to be cautious about that because you just can't transmit a laser beam through the Earth's atmosphere because you're causing perturbations of the laser beam and things of that sort. So one option is to have a relay satellite orbiting the moon and Earth, and they transmit the communications between those two, and then down, whether it's from Earth to the relay to the moon relay satellite, back down to the moon, and then back up and all that. So we're still looking at options, and of course, we have the what we call the disruptive tolerant network too as well, that we're also working on too as well, to mitigate the effects of losing communications, especially during critical times.
Awesome, amazing. Okay, so the next question that I have here is more into the ethical side of things, right? So how do we make sure as private companies and also obviously the governments, how do we make sure that our lunar exploration and the commercial activities that are taken, they are in an ethical way, following the sustainability and following the safety as well? So what are some of the ways that can be ensured? And whoever would like to take this.
I'll take that.
Sure.
So first of all, our big problem right now is if Queen Isabella would accurately and right-size the funding for us to get to the new world, then we would actually be able to get to the point of having this lunar economy being built, right? So that's our first challenge. Second challenge is the brute forcing of humanity's permanent or at least semi-permanent existence on another terrestriality, which has never been done. So we've got so many obstacles that people don't understand something. Here's what happened. 50, 60 years ago, we had a space industry that was brought upon by a military endeavor. And it extended all the way to the point of planting a flag and then retreating to say, okay, we've taken this hill, now we go backwards. There was no consideration for an economy being built that far out. Now, when the space industry became lackadaisical in its effect, what happened is Hollywood picked up the baton. When Hollywood picked up the baton, they could go as far as the Orion Belt and give you starships and give you everything. So there's been a couple of generations of us raised in thinking space is so sexy and we're going to go from space shuttle straight to the Death Star. So the challenge there is that there's expectations are way too high and the reality of space is way too hard. And in there, if you cake in, I'm not saying we don't need ethical considerations, but if you cake in too much of that up front, then you're already limiting what is already a mission impossible. So I think ethical standards and concerns are highly warranted, but they should be placed in consideration of how difficult lies our task vis-a-vis what's happened to the psyche of humanity over the last 40 years, where Star Trek and Star Wars has given us this illusion of space being an easy slip into the heavens rather than what it really is, which is the greatest, yet the most difficult journey humanity will engage in.
That's a fair point, and I absolutely agree with what Jaden says. That's it is important to pay attention to those things, but we should not let those things also tie our hands up, right? When again taking up this endeavor. So we can move on to the next question, I believe, which is again some of the we're already on the moon now. We're already on the moon, and now we're talking about the use cases of, let's say, some of the technologies like 3D printing and just the role of that in developing the lunar infrastructure and the lunar settlements itself. So what are the roles of the 3D printing and the in situ resource utilization also? So we can touch upon that. So who would like to go ahead? Yeah, sure. Kev, go ahead, please.
I mean, there's I think the coolest laser that I've come across was a laser that was being designed to melt the lunar regolith and build it up into a habitable, habitable building. And I think, these kinds of things where, Jaden's talking about how there is a lot of difficulty in space exploration and kind of setting up these infrastructures. But then there's also this other technological leap that we've made since the 1980s, and you look at what we've got today, we've actually got quite a lot of new ideas and systems and tools available to us that we kind of can breach this kind of like weird new zone of printing your own house out of nothing. So you don't even have to take up materials and things. No one would have really have thought of that other than people who make mud huts, and thinking about, buildings and things in that kind of sense. But I do have to echo that it's the desert of all deserts. And, when you think about how difficult it is to live outside when you don't have cities and you don't have that infrastructure, you don't have the utilities on hand, you kind of also naturally get into a framework. You talk about establishing the regulatory framework. And I think, what's important to know is, and I think what Jaden was touching on is it is quite alien versus what we have on Earth, that we can't just copy and paste what we think works here and apply it there. There's that kind of the brutalness of the environment is going to dictate how you do things more than we've got that freedom to decide before we kind of go and do it. And I think, just managing that next burst of activity that might come through, when technology becomes so accessible that millions of people can start their own projects actually commercially without a government holding their hand, then I think that's really the point at which we need to get serious about how people make decisions and the things that we can do.
On that, I want to add a point. We have to think outside the box. While iterative patterning, which is what 3D printing facilitates, what we will need is to do something out of the box. As an example, if you take particular branches of mushrooms and DNA tweak them, you can change their texture and structure where you can grow them to be larger and then cut out bricks from them to create your construction material. And all you have to take from Earth is spores. Instead of heavy lifting, because Earth's gravity well is quite profound, instead of even heavy lifting all that, the XYZ axis infrastructure for a 3D printer, you can actually just have the mushrooms be not only a source of food, but another type of mushroom be the source of the building material, which you can cut and create the bricks in order to facilitate probably sealing of the tunnels, if there are any on the moon, in order to facilitate living underground. Living on top of the ground offers you so many obstacles to deal with that it would be better for us to become cavemen again, rather than for us to have the adventurism of being on top of the land, and that puts us at significant risk, which we can reduce if we go underground and seal up a portion of the tunnel, heat it up, get the food, put the aquaculture, and start the process of our growth over there. It's hard enough as is. We're going to need to learn to simplify things rather than complicate things based on Earth dynamics. New out of the box thinking will facilitate that permanency that we all desperately are seeking.
A lot of great points. Just on the question around ISRU and kind of what some of the applications of that are. I mean, I think they're quite broad. We run an ISRU company. We are the prime contractor right now for the work the CSA is doing. Canada is the world leader in natural resources. We have the biggest mining industry on the planet. And the Canadian Space Mining Corporation's right now doing all the long-term planning and architecture for the CSA. I think there's a number of innovations that are going to come out of space mining applicable to a broad range of areas. Certainly water processing, if you look at like water treatment technologies and how those have derived from space, the challenge obviously of making drinkable water in the lunar environment, I think is a big one. You have these restrictions of kind of weight and mass. Bryce, as you were talking earlier about just like the cost of launch, right? That is such a restricting and constraining factor where we are so energy and mass constrained that I think the ways in which we will do mineral processing, water processing, resource detection, all of these activities have huge ability to disrupt large parts of industry on Earth and parts which touch our kind of daily fabric of our industrialization of this planet. We use resources every day. We need to find ways on Earth to make them, to discover them more efficiently. We're working on ways for that. We're working on ways for doing processing of resources more efficiently. Water processing is water technology for water processing is $1 trillion market. So there are certainly a lot of positive innovations that can come out of this space that are already being developed by companies like ours, and I'm sure some of these other ones, and can help solve some of these big problems on Earth, and will obviously touch people's lives in a bigger way on Earth than they will on the moon.
That's a lot of great, again, issues that you mentioned also, and a lot of great technologies that need to be developed. So that's also coming back to the point that I think Bryce mentioned earlier, that basically the government is holding hands with the companies at the moment. But only with the government support, it will be very limited to, again, accomplish all this heavy tasks that there are, right? creating this resilient and self-sustaining economy as a private side. So how would you propose, and what is your standpoint on how should the companies that are working again to develop those technologies for the lunar exploration and settlement, how do they communicate their importance and their value proposition to private investors to attract more investments?
Well, there's so many resources on the moon that once we're there, there's a plethora of amount of resources that are worth trillions of dollars, like Daniel said. And once an investor truly realizes that capability and that potential, and I think it's more of like a chicken and egg scenario where we have to get there first. You know, no investor is going to pour a lot of money into a project that might take 20 years to come to fruition. When realistically we could be doing it maybe 10, it might be 30 until we're talking about the kind of things that we're talking now. But once we are there, investors are going to just be knocking down the door trying to get a piece of these. So I think it really just starts with the development of the technologies and really just proving that we know what's up there and we know how to extract resources and utilize them.
I think you've either got to find an investor who is okay, losing money and pouring money in for the next 10 years, or you've got, or probably more likely and to happen, you've got to find a viable business opportunity that works on the way to getting to the moon, where you're developing a technology where you see a bigger market on Earth than you do on the moon, developing the technology for the moon for NASA and other space agencies will pay for the development of that technology. And what it leaves you with at the end of the day is a technology that can go to the moon and a product that can be commercialized on Earth so that you can have a viable business. If you look at the first generation of space resources companies, right, the planetary resource of the world, I think that the big takeaway I take away from that is you have to be solvent to make it to the moon. And so, it's no good having the best idea if you end up bankrupt long before you get there. You've got to have a viable business all along the way. And if you can convince the government to be your customer and fund you for the work for the next 10 years, then great. If you can convince someone else to fund you, then great. But you've got to find a viable model, however you do that.
Wonderful.
I think, humanity missed its golden opportunity, which was in the 70s and early 80s, to expand the space industry, because there was so much interest, so much capital ready to be deployed to that industry. So what happened is that delay and us missing that window of opportunity, now when you look at capital's attraction or interest, they look at everything. Running Celestial Ventures, we invest in space startups. Everybody looks at the window of time and the return of your ROI. And there are so many, since 1980, you got personal computers, then you had the internet, then you have where we are today. So space now is woken up from the 70s, flash forward now and says, guys, provide us capital. But now capital has so many other attractants which have shorter timelines. So now space comes along and says, hey, I've got a 10, 15, 20-year timeline for you. And it's like, okay, well, why am I going to deploy X amount of dollars and get that money back in 10, 15 years? Or I can just get that in 3 to 5 years, investing in a new Instagram or new this or new that. So the challenge for the space industry is that it waited a little too long. And now it's coming back and it's trying to be, it's trying to get that sizzle back or its mojo back. However, there's way too many other opportunities for capital deployment. And that's one of the big struggles. Now, I'm not saying that we have a solution for that problem, but I'm saying at least we need to identify the problem. And that is the biggest one. The timelines are too long and the opportunities for capital deployment are too great and too varied for space to be the darling that it was in the 70s.
I think there was a significant difference, though, between the two models, and also when you consider the quality of the engineering and the technology that needed to happen to make those programs actually function. it's a lot of hand done calculations, people who've like really continue their studies and research to actually understand how to make this thing happen. I think we take it a bit for granted how much has changed from that time period to now, and how accessible that information is, and how you can start playing around with Kerbal Space Program and you suddenly becoming an amateur orbital dynamicist. There's so many different things here that are opening up people's minds into what is possible. And I think because of that situation, you had long-term expensive programs that you needed a very specialized small group of people to really focus on and just give them the cash to make it happen. Today, you've got a lot of technology, you've got a wider pool of people who understand at least the basics that can help. And then you've got you've got your kind of like small group that actually enact and can finesse the final product. And I think we're going through that period of getting into that shorter term kind of like business model where you can see shorter returns from, I think it's like ancillary industries, right? So you're designing a propulsion method. That's not just a propulsor, that's also a heat exchanger that can be used in fusion reactors and different other scenarios in heat regeneration plants. And actually that's, I think, the real kind of like ticket that's coming out with the space industry, is that you get so many strands of technologies just by solving this one big problem. You actually get 20 different businesses out of it. And I think that's as we start to grow this industry, and I think that's what's happening, is we're just seeing this go through a different phase. And now that we're in this new phase, we're kind of like starting to see that someone just thinks, oh, why don't we have a 3D printer in orbit, and starts to come up with some cool ideas and different businesses for that. And I think that's what we're trying to. I think that's what we're seeing, is this new evolution of the industry, rather than I think us kind of feeling bad that we missed that window. I think we're making really fast steps into accelerating and getting back on track.